Hi and welcome to another episode of TRX Bench. Today we have a nice Kenwood TS-480 here on the bench. You can already see it here in the background, and it is running because we are expecting a frequency error. And I just wanted to let all the oscillators running warm that if that is true, that we directly can go for alignment. But I really have to tell you the story behind it, because it is really a kind of a shame for the dealer who sold this unit to the old man. So, you know, the old man went for another radio, for a new radio, and he purchased this TS-480. And indeed, the TS-480 is really a nice radio, so nothing to complain, right? Then he took it home, of course, and he was really curious to go on air. And then suddenly he recognized, when he dialed in a frequency to another station, and he was trying to answer the station, something is wrong. So he often heard, you are off frequency or such. So all a little bit mysteriously. And so he went back to his dealer, and of course during a warranty. And the dealer checked the radio out and told him, no, everything is just fine, maybe a little frequency error, but that is not a problem, so you really can use the unit without any problems. So far, so good. So he went back home and tried to operate this radio, and you know, he was never satisfied until he met a friend of mine, and he said, hey, let's test it. So that all sounds a little bit odd. And he found that the radio really is off, really a big delta F. So, you know, he called me and said, hey, can you really put this radio onto your bench and check out if you can verify what I have found. And if it is what he has found, and he's told me that he has seen a frequency error of 500 hertz or so, and we really want to verify it. If that is really true, then believe me, that is really a shame on the dealer who told the old man everything is just fine. Okay, so let's see what we can find, and let's see if we are able to help the old man. Okay, and here is our TS-480, and yeah, radio is already warm, so all local oscillators and of course the reference oscillator should be now stabilized, so we really can go into testing it. And of course, whenever I have to do a critical frequency alignment, I verify that my frequency counter is still calibrated. I mean, it is an external OCXO which is running here, my frequency counter and my Rotor and Schwartz and my HP generator. So this all is going here over my distributor, and you see I'm verifying the accuracy with my rubidium standard, and you see it is really nicely calibrated, so that is rock solid, and we can believe what we see on our frequency counter. Okay, and I have the radio set to 10 meter band, and I've set it to AM, and I do not need full power, so I've set it to 20 watt output power, and I can transmit here, and you can read here on my display. Sorry, that is a bad camera work. So we can read here, yeah, approximately 20 watt, so that is just fine. But we are really now curious what will be our output frequency. Okay, and I have connected here my radio with the frequency counter, and radio is dialed to 28,500 megahertz, and now I press PTT. I do not talk because I do not want any peaks from the modulation. So I really just want to see the carrier. And now let's go. Okay, and once again, both is warm. So our radio is warm and our OCXO is warm. So every frequencies are locked so far, and what you see here is really a bomber, right? So again, we have 28.5 megahertz dialed in 10 meter band. When I press PTT, you see what we get. So 28,499,307. Okay, so that means we have a delta of 693 megahertz, and that is really, that is unbelievable. That is incredible. If a dealer is telling you that that is only a bit, so no problem, you can use it. Really, I don't know what I can say. So that is really a huge arrow, and we really need to align it. So unfortunately, this is not a joke. I can't believe it. I mean, a dealer who has a lab, so he has a workshop, and he is able to do exactly the same what I'm doing here, and no, I can't believe it. Okay, and I just wanted to reproduce what the OM has experienced when he was trying to get in contact with another station. So for the moment I have connected here my communication tester to the radio, and you hear on 28,500 our RX seems to be fine, and even when we watch our figures on the tester, you see it is just fine. So we are sending an AM signal with 30% modulation, and we see on one hand that we get a feedback of 1 kilohertz, because that is of course our modulation tone, and we see we have a nice synod here, and we see that our scope signal, so the sine is very nice and clean, so everything is fine. But when I now key the unit and we go into transmit, let's see. First of all, we have our 20 watt, but here we have exactly the same frequency arrow. Then we have it here on our first test, okay? And that is what our old man has experienced when he was trying to get in contact. And the problem is more worse on the higher frequencies than on the lower. So when we go down to the 160 meter band, then our frequency error is not that huge, and that is of course telling me that our PLL is involved. So I believe that our PLL circuit is getting a wrong ref frequency, and that is of course what we need to investigate. And that you see the difference, I've dialed the radio to the 160 meter band, 1.9 megahertz, and let's key the radio. And what you see here, so here our frequency difference or our frequency error is not that bad. We have one digit more than we had it with the 10 meter. So just forget on this figure here, and you see 899953. So that means our error is approximately 50 Hertz. So for AM that wouldn't be a big deal, or for FM no problem. But for SSB it is already too big. So I just always state that 30 Hertz might be okay even on SSB, but if the frequency error is more than 30 Hertz, then you can definitely hear it. And 50 Hertz can be heard on SSB, and again we are on the 160 meter band. So let's do the same test on, yeah, somewhere in the middle, maybe on 20 meter band. Okay, so let's do the same test on 20 meter. I've dialed in 14 megahertz. Let's see. And here you can see that it is already a joke. Yeah, so now we have again here, so that is the 1 Hertz area, and you see 659, so that means we are 341 Hertz off, and for SSB that is already a joke. So this radio is so heavily out of frequency that I really can't find words, and I believe it must have been already when the unit was new. So out of the shelf it was off. So you know, that is definitely something what would have needed to correct during warranty, but it hasn't. And I really honestly hope that it is only an alignment we have to do. I really hope that there is not an odd, really serious fault in this radio, because then, you know, that is no fun any longer. Okay, let's have a look first here in our frequency configuration. And well, what we see here, basically here our X1 is of course our reference crystal, and if there is an option installed here in the radio, then that is a TCXO. Otherwise it is a normal crystal we will see. We have here a frequency doubler, so that we have 31.2 megahertz, and that is of course the frequency we need to check, because both DDS generators are using this 31.2 megahertz as a reference frequency, and if that frequency is already wrong, then of course our PLL is working on the wrong reference frequency, what means that of course as higher we go with our bands, as bigger our frequency error will be, and that is what we see here on the radio. So I just want to see what the alignment procedure is telling us, and then let's go through these steps. Okay, and here's a PLL section, and funny enough it directly starts with local oscillator 2, which sits on 62.4 megahertz, and there is no alignment for LO1, and that is a little bit odd, because we have seen on the frequency configuration chart that it is really important to have precise running LO1 to just give the right precise reference frequency to our DDS oscillators. So that is a little bit odd. So let us have a look into our schematic. Okay, and we are here on TX-RX unit, and here is our X1, our reference crystal, and yeah, you see our 15.6 megahertz, and well, they told us to align the LO2, and this here, after the frequency doubler, here you can read, that is the doubler section, we will have our 30, what was it, 2 something, or 31 something, don't know, not 30, 31 something, it doesn't matter right now. And well, that was the question where I said, hey, we need to align LO1, because LO1 is the reference for the DDS sections. And what you can see here is that here we have our TC1. Let me see if I can zoom it in a little bit, that you can better see it. Yeah, so X1, and here's our TC1, and that is a variable capacitor to align here our X1, and that makes sense, because otherwise, if we only would have aligned LO2, that is not possible. So let's go to our alignment procedure, and remember here our TC1, which is directly connected to LO1, or better said, to the reference frequency. LO1 is behind our doubler circuit, right? So let's go back to our alignment procedure. Alright, and here again is our PLL section, and you see we are aligning the 62.4, but we do it with TC1, and that is a good one, because it is really, yeah, let me go to the frequency page. And here it is. So you see we have here a doubler, and we have here a doubler, and we are testing our 64.4, and that makes sense, because now it is even better to align the higher frequency, because when we are able to align this to 62.4, then our error is even smaller if this is already aligned to 60.4. But in reality, we are down here with our TC1 variable capacitor, so we are really aligning our X1 frequency, so directly the reference frequency. And what you can see here, after the doubler we have the 31.2, and that means if we read a good 62.4, that subsequently means that of course our 31.2 is fine as well. So let's go here for this procedure and let's see how we really can manage it. Okay, and now we have to do first of all the right settings. So you see we have to set our frequency to 14.2. So we should select upper sideband, and we have to disconnect the cable from CN1 and insert it a cable from the frequency counter, or with other words, we directly connect this CN1 to our frequency counter, and then we should read 64,400, which we will check, of course, and have a look what we can see here. So we are allowed to have a delta of plus minus 30 Hertz, and that is what I already told you. I would accept 30 Hertz as frequency error, but not more, not 300, 400, 500 or even 600 Hertz is the right delta. And you know, still it is a joke what we found here. But okay, let's go to our terminal CN1 and let's see what the frequency is we can read there. Okay, so I have prepared here my testing, and you see that the screws are off, but I let the lid here over it because the reference crystal is directly under it, and if I take it off, then of course we are changing the temperature. So therefore let me take it off, and we need to take off CN1. Let me double check CN1, which is this here, and we have to put here our frequency counter in it. Alright, and then we have to check our frequency. Okay, so I have connected here my counter to our LO2, and I put the lid back over it just to keep the temperature around our crystal, because otherwise it would drift and our test wouldn't be fine. Additional to that, I did here all settings which were described in our service manual. So 14.2 megahertz, so we have set it to upper sideband, and now we should be able to read 62.4 megahertz on our frequency counter. Let's see. And here is the result. And the result is a kind of shocking. Remember, the allowed delta according our service manual is plus minus 30 Hertz. Okay, so our frequency, what we should read here, should be 62.4. Okay, and we read 62 just fine, 398,483. So that is more than 1.5 kilohertz, so 1517 hertz, where our oscillator is off. So no wonder, really no wonder, that the radio is completely off frequency. And once again, shame on the dealer, really, shame on the dealer. Now we try if we are able to align it, and well, 1.5 kilohertz is a lot, and I'm not sure if we can align it with our little pot, but we try, of course. Okay, so just to let you see what we need to do. So here is our frequency counter, okay, connected. And down here, so that is our crystal, okay, that is our reference crystal. And down there we have our little adjustable capacitance down there, so that is TC1. And of course we try now to align our crystal to the right frequency, okay? Okay, so let me try to align it, and you can directly see the result. There we go, in the wrong direction, so let's see. Come on, what is going on? Come on, yeah, that is nice. Yeah, we are obviously able to get it here in the right way, and of course this little caps are very, very touchy. So maybe it is possible, and it is normal. It always takes time. You can't rush. And you see just a little bit too much, and we are over our point where we want to go. Okay, so we are relatively close. So now we would be in the allowed tolerance. Our lid is open, so I stop the video now. I put back the lid and check if we are able to hold this frequency. Alright? Well, the cap at our crystal is very touchy, but it has stabilized a little bit, and yeah, we leave it running still a little bit. It is moving a little bit up and down still, but you see it looks quite nice up to now. Still the lid is over it, so I always take it off for corrections, but after that I directly put it back on to hold the temperature inside. Well, whenever you buy a new radio, never buy a radio without a TCXO, which is a voltage controlled oscillator. These normal crystals are a kind of pain in the back. So really, if you buy a new radio, you should have a TCXO inside, because then your frequency is more or less stable. Whenever you have a configuration like this, you are always in trouble. Okay, it's now 1 hour later, and the oscillator is still moving back and forth, and that is the problem if you have only a normal crystal. And even when we start transmitting and the radio is getting even hotter, then yeah, you know, the oscillator will move more, and well, so it is. But anyways, let me just put here the right connections back together, and then let's see how it looks like on 28500. Okay, so that is now the step where we take our counter off and we put back here our real wiring into the circuit, and of course as it is moving back and forth we put back here the lid that we still get our temperature stabilized. And now let's see how it is working on real frequencies. Okay, so let's stay here on 1420 for the first test, because that was the frequency where we aligned our radio. And yeah, let me go up to the counter. Alright, so real working condition, 14.2 megahertz, 20 watt output power and AM modulation. And now I'm keying the radio. Wow, so that is a difference, isn't it? So exactly what it should be. Great. Let's go up to the 10 meter band and let's check it there as well. Alright, so I'm now on 10 meter, 28,500. Let's see. 28,500, that is what we want to see. Exactly, great. Okay, now our communication test set here is back in late. And yeah, we can take it off, and you see receiving is just fine. And of course here our audio frequency, which comes back here to the test set, is 1 kilohertz. The sign is nice and crisp. And now let's key the radio, and that was the situation where we had this huge frequency offset. And if we have now no frequency offset, everything is back in the right way. And here it is. So you see our 20 watt, and it is exactly now on frequency. That is exactly what we want to see. That is great. So radio is now rescued. Okay. And again, the same game here on the 20 meter band. So our receive is great. Now let's key. 20 watt, 14.2. Everything is just fine. Okay, so what can I say? I have to go through our service manual. I will do some additional steps, but the problem itself is solved. And once again, that is definitely something what the dealer should have seen. And this is clearly a warranty issue, but the radio of course is out of warranty. It is now 4 years old, and our old man really is using it for now 4 years without being satisfied, and that is really a pain. But anyways, I hope you will be satisfied right now. Again, I will go back into our service manual. I will check some additional steps just to be sure that everything is just fine. But I do not want to drag out this video much too long, so I just want to stop here, because you have really seen the most important steps, and I guess we all are happy that the radio is now really working great. So let me stop it here. Thank you very much for watching, and yeah, catch you over the next time.